let's check if the audio is on, ladies and gentlemen. Okay, good afternoon, morning. I don't know what it is. I graded your exams. You guys probably are aware of that. I will send it to you. I'll pass it back to you guys today. I want you guys to know you did very well. You did an excellent job on this exam, and good for you. It was a pleasure grading it. It was easy to grade. It's not always the case when you grade calculus exams, especially calculus 2, because there's always some funny things that happen in calculus 1, and especially since the pandemic. You get students who have done things they probably shouldn't have done, like use apps and stuff like that. Really, that's the bottom line. Calculus 2 class, it's good to see people who have, looks like have not done any of those kinds of things. So I'm really happy to know that. So it was a good experience grading your exam. To let you guys know some of the dangers in the past. Sometimes, when students have done those wrong things for themselves, they don't realize what they've done to themselves. For example, I had a group came back after the pandemic, Calculus 2, that did some very bad things. They shouldn't have done it. And, they're in Calculus 2 and they didn't really know Calculus 1. They didn't know trig. They didn't know pre-calculus. And they did some things. They admitted what they did. They used apps. And so they asked what to do now. And the answer was very simple. You got to go back and learn the material. Okay, there's no other answer. And for some of those students, don't know whatever happened to them. Some of them were like transferring that semester. Was not a pretty picture. So, there's a reason why I say to you what I say to you, is because you may not see it or you may not know it. It is completely for your own good. But so you guys know you did a very good job on it. I'm very happy to see that this is not the same experience as the past in Calculus 2, where students have done some things they just really should not have done. And I don't have to tell you guys, because you guys talk to each other and probably a lot more aware than me of what goes on and what people do. But that's good. It's good that you guys have done a very good job of your test 1. So I'll pass that back to you guys. And congratulations to you. Good for you. Good job. So I really enjoyed that experience. So I like to get your test back quick, as you guys can see. I try to. So 3 out of 4 tests were back the very next day. Some tests were graded 3 tests were graded that very day. You guys took an extra day. I usually take the calculus class. I usually grade calculus last, because you got to read that stuff. You got to go through it. You got to read. You got to scan what you're looking for. So that does take time, So it's interesting. So usually, like I said, the calculus courses take a lot more time to grade. It's a lot more work, especially when you have large classes. Like I typically have large classes. So got the grading out of the way, and I think it's important because what you want to illustrate to students is you want to practice what you preach. Meaning if I say, you know what, you got to get to your homework, it's important, make sure you do that. That applies to me too as well. So, it's important to practice what you preach and be exactly that. So I did. Did you just that? I got your work for you guys done. You'll get it today. And again, congratulations to yourself for that. Okay. I think I did send you an announcement for some extra credit. Is that right? So if you guys wanted to, I got a request from CJ, for the AMATIC contest. If you're interested in doing that, for participating, I forget what we said, how many points it was. I don't know. 15, I don't know. I think I put it in writing. And if you finish in the top 10 or top 5, was it? Yeah, top 5, you got like 10 points too. So that's a reward for those who finish in the top, whatever, 5. So that's that's kind of a rare extra credit opportunity. That's not like, hey, wink, wink, I'm not passing, Mr. Judge, give me extra credit, right? That's more of this is for everybody. Hopefully you participate and have some fun, and then just see how it goes. So just send that to you guys. Anyway, just anybody here thinking of participating and doing just that? Okay, so have some fun and see how that goes. No big deal. All right, so what were we working on yesterday, if you guys remember? L'Hopital's rule and the indeterminate what? Product, right? Well, we started with the quotient. We transitioned to the what? To the product. And you got indeterminate forms now for the what? For the product. And anything that looks like this, infinity times 0, 0 times infinity is going to be a what? Indeterminate product here. And okay. And then this is your fix. You convert your product to what? To a quotient. So on the left is a product. As you guys can see, this is a conversion. And on the right is your quotients. And what this will do, this will always give you your indeterminate quotients, assuming you have an indeterminate product to begin with. So I have a whole bunch of examples, like I said, that I've gone through. And this was the first example that we did yesterday. So let's try another indeterminate product. And again, I find students do well with L'Hopital's rule as well. But, you know, again, there's one issue, and that's always what you face for an indeterminate product. So when you go through tangent pi x over 2, natural log x, we're looking at the limit as x goes to 1. Now, what's nice about this is both of these functions are continuous around 1. And so you might say, okay, well, what does that mean? Well, because your limit's going to what? 1, you plug in the value 1, because they're both continuous around 1. So you get pi over 2, natural log of 1, and I take that back. I don't think, are they continuous around 1? I don't think so. I take that back. What's going on here? Does anybody know? Tangent 90 degrees. Uh-oh. I think maybe we should do something like this. Let's go from the right, okay? So what's going on with tangent pi over 2 to the right? Do you guys know? Where does that limit go to? How do we think of that one? Anybody remember? What's going on with tangent? Anybody remember about graphing tangent? Tangent kx? Where do you have your vertical asymptotes? Anybody remember? Is that negative pi over what? 2k, positive pi over 2k? Tangent's good for that interval. So here k is going to be, you know, pi over 2, I guess. Yeah, so just to kind of have you guys remember some of this stuff here. Because you might say, what would I say about this? How would I think about this? So if your k value is pi over 2, right in here, just going through some more graphing with tangent here. Pi over 2, pi over 2. That interval is really from what? It'll be negative 1 to 1. So this is the location of vertical asymptotes here. Okay, and your tangent curve, if you guys remember, looks like this. All right, you guys okay with that one? So what's the limit as you go to 1 from the right? What's that going to be? Do you guys know? This limit's negative infinity, right? And then what about as you go from 1 to the right of natural log? Do you guys know? Oh, natural log is continuous at 1. Okay, it's continuous at 1. Now you say, well, how do I know? Well, go to your natural log curve. Think about that curve. These little details are important, right? So as you go from 1 to the right or the left, natural log of 1 is over here. Is that true? That location is 1, 0. So what is that answer going to be? Isn't that 0? So here's my point to you guys. This is an indeterminate what? What is it? Isn't that an indeterminate product? So when you have an indeterminate product over here, indeterminate product, what's the story for the indeterminate products? What do you got to do? You got to fix that. Is that true? All right, so you got to fix that. You got the F curve, you got the G curve. So you got two choices here. We either write this as what? F over 1 over G or G over 1 over F, because these are all equivalent. That's the algebra fix. The real issue is which curve do you write as a reciprocal and which curve do you leave? Right? Which curve do you leave as a denominator and which one do you use as a reciprocal? And I'm sorry, which curve do you use as a numerator on top? And which curve do you write as a reciprocal on the bottom? Because, you know, arithmetic, if you guys know, F divided by 1 over G is F times G. G divided by 1 over F is F times G. This is what we call the fix. It's the algebra fix. And so that's where your issue is going to be. You're going to go, I don't know which one to write as a reciprocal. I don't know which one to leave as a numerator. And the real answer is, well, try both. Right? That's kind of the real answer. The real answer is try both. And in one case, the derivative will be easier to do than the other. That's really what's going on. There's only two routes here, and one is easier. And that's the one you choose. Which one would be easier to take the derivative? So when I look at this and you go, well, what would I say? Well, by experience, by experience. And how do you get there? You only get there by experience. And you can't substitute experience. Okay, so that means you got to try some of these out. So by experience, I know, you know what? I don't want to write the reciprocal of natural log. I can. I think it's actually going to be easier to keep natural log as a numerator. And so that's what I'm going to try. So I'm going to try that here and say, I'm going to fix this. You now have the limit, x goes to 1. I'm going to leave that natural log up here. And now this is 1 over tangent of what? Pi over 2 what? X. Is that right? And so do you guys remember in trig, what's 1 over tangent? Anybody know? Isn't that what? Anybody know what's 1 over tangent? Isn't that cotangent? Okay, is that true? Isn't that cotangent? You're writing the reciprocal of tangent, which is cotangent. So now you might say, well, what does that even do for us? You're going to get 0 over 0 now, ladies and gentlemen. Okay, this is the indeterminate quotient. This will always happen. You write the indeterminate product with the fix, you'll get the indeterminate quotient. You didn't have to check the cotangent curve, but you can if you like, right? So, okay. What does L'Hopital's rule say then you get? You guys know? Well, you got to differentiate. I'll do that here. I'll write the notation. So we started to get used to not writing the notation. But for this first warm-up, what do you guys get now? What happens with the derivative of natural log? That's 1 over x. Is that right? And then, let me write it a bit clearer for you guys. And then what's the derivative of cotangent? That is a Calculus 1 question, but this is a Calculus 1 question with chain rule. So what's the derivative of cotangent? Do you guys remember? Calculus 1, it's negative what? is negative cosecant. Negative cosecant pi x over 2 times, what's the derivative of pi x over 2? Not pi over 2 by chain rule. Okay. And so now here you say, I got the limit of, let's see what we have. We got 1 over x, just to kind of write every detail, minus cosecant pi over x over 2. And a lot of times we put that factor of pi over 2 out in front. So we'll do that. So you're going to have to do some algebra here, right? So what does the algebra say this becomes? You guys know? You get 1 over what? This will be 1 over negative pi over 2 with the x here, cosecant squared, pi x over 2. Now what I'm going to also do is use the reciprocal of cosecant, okay? Because maybe you think, well, that might be easier to do some arithmetic. So I got minus sine squared pi x over 2 over now that negative pi over 2x. So that might be a little bit easier for the arithmetic part. And what do you guys know about 1 and these functions? These functions are nice continuous at 1, right? They're actually continuous everywhere, aren't they? Those two functions, numerator and denominator. So why do I care? You just plug in 1 for x. Isn't that why we care about continuity? So if I plug in 1 for x, don't I get over what? Negative pi over 2. And you got to know what this is by definition, sine squared. Sine squared is really, you know, sine to the second power, right? Just put the power there. Now, what's sine of pi over 2? What's sine of 90 degrees? Again, in my mind, I think of the curve. So maybe you said, okay, Mr. Judge, you know, because there are people like that, right? They believe it or not, they take courses with, they skip prereqs. So, and it's interesting here. You know, I'm sitting on a statewide I'm sitting on what's called an ICUS committee. It's where the academic senates of the 3 higher ed universities get together. And it's actually math people, only math people. So I'm like, there's 3 community college faculty. That's me, 1. 3 CSU math, 3 UC math. We're writing what's called a white paper for the state of California about math competency and what students need to be successful to belong in STEM careers. That's me writing that. And, you know, I got the email yesterday, about some paragraph we're trying to talk about the role of trigonometry in STEM. What do you think the role of trigonometry in STEM actually is? It's big. Trig's like the language for some. So it's like if you're going to take a physics course, you can't take it without trigonometry. 90% of trigonometry is 90% of physics is trigonometry. You know, so try that out. If you said no, Mr. Judge, it's going to work out for me. Okay, good luck. But it's ironic that I'm writing that right now. I got to go home and later today do some writing and thinking and go, okay, what do I say about this comment here? The easiest thing to say is, don't try it. If you don't take trig, don't try it. But, you know, so you say, what does that have to do with me? Well, because again, why do I say this? You may not know, but yes, down the road, you'll start to see here in Calculus 2, Calculus 3, and the science courses, trigonometry is big, but there are people who do it without it. So what I'm going to do with that, I'll give you a nice free advertisement. I got my trig site the new version, because the old one, I won't go through all those details, but I'm setting up here. I think if I have some of these things, it might already be. I'm actually working on it as I go along. Here's graphing trig functions. So maybe you guys want to take a look at some of the graphing trig functions. If you said, well, I don't know how to graph, right? I don't even know what you're talking about. Well, you got all this detail. Look at that. You got videos, and there's going to be worksheets and solutions here. Some of them, they're already even here. So I'm just going to update it, but, you know, I'm working on this as I go along. It's part of my old site. So it's going to be there, and as you guys can see, you might want to make use for it if you said, you know, Mr. Judge, I don't know what some of these things are because, you know, you don't. Well, how do we figure out what sine of pi over 2 is? Do you guys know? Without a calculator even. You might say, why is that so important? Well, where you're headed, what's the deal? It's kind of like spelling, you know. You got to know the answers as you go along. So what is sine of pi over 2? Do you guys know? Because I can tell you what I think of. I think of this. I think of the sine curve. In this picture, I guess we'll do it this way. This is not a trig class, but isn't that the picture that this is a picture I think of? So you say, okay, that's 0. What's this? Anybody know? Pi, what's this? 2 pi, what's this? Pi over 2, what's this? And then the altitude is -1 and +1 here. So what I'm saying is this location, sine of pi is what? Is the number what? 1. I didn't reach a calculator, you know, I try to figure out what that is. So that's kind of an important thing, you know. And then what's 1 squared? Is that 1? Okay. So far we get 1 over negative pi over 2, which is really what? 1 divided by negative pi over 2, and then 1 times a -2 over what? Pi. What's your final answer? -2 over pi. So, ladies and gentlemen, there you go. All of that detail. So, if you're strong in the basics and the fundamentals, you could do a lot. That's all. Strong in the basics. Okay. What do you guys think? That's a pretty good question. Should I give you guys another good one? How about the limit x goes to infinity e to the minus x, x cubed, oops, let's put a minus sign here, minus x squared plus 1. Okay. I think that's a plus. Okay, is this a product, ladies and gentlemen? As you see it, it's a product. Is that true? Right? So you got F and you got G. Okay. So what's the limit of F here? Do you guys know? This is a test question. Is that exponential growth or decay? That's decay. So as it goes to infinity, what's that? This is going to be what? 0. And then what's the limit of x cubed plus x squared plus 9 as x gets big? What's that one? That's like a calculus 1-ish question. Isn't that infinity? Good. Indeterminate what? Product. So what do you do here? We got to fix it, right? So which function do you think would be easier to take a derivative if you write it as a reciprocal? Because we got to write this limit question as a what? As a fraction. Is that right? So which one do you think would be easier if I write it as a reciprocal? You think it'll be easier to write, I got my first function, second function. Do you think the quadratic would be easier to take the derivative if we write it as a reciprocal? I don't think so. So I'm going to leave the cubic. I'm going to leave it where? Here. So I'm going to write my f function as a reciprocal. Right? Okay, you guys okay with that? Now, here, you might say, what does this become? Do you guys know? What is that going to be? 1 over, do you guys know what this is? Let's do a little bit of algebra, right? So, isn't that e to the minus x, maybe to the negative 1 power? And then, what is negative times a negative? So that's e to the x. So, ladies and gentlemen, the limit x goes to infinity, x cubed plus x squared plus 9 over what? E to the x. What do you think you get again? The indeterminate what? Quotient. Promised to you. Where this is where you apply now what? L'Hopital's rule. So, by L'Hopital's rule, this will be the limit as x goes to infinity now. What's the derivative of the numerator? Do you guys know? Isn't that going to be what? 3x squared plus 2x. What's the denominator derivative? E to the x. Good. Okay, we know some of those basics. Now, if you apply the limit as x gets big, what's the story again? The numerator goes to infinity and the denominator goes to infinity. So, okay, what do you think you guys have to do again? L'Hopital's rule. So the limit as x goes to infinity, that numerator is going to be what? 6x plus 2 over what? E to the x. And the limit for the numerator is infinity. The denominator is infinity. So, ladies and gentlemen, apply L'Hopital's rule again. What's the derivative of 6x plus 2? 6. What's the derivative of e to the x? E to the x. And so the question now is, what's this limit going to be? Where is that going to go? Do you guys know? So be careful here. I would say to you, think of it as this. You see this 6? Think of this as 6 e to the minus x. So that I can pull out the constant 6. I take the limit as x goes to infinity of a decay curve. What's the decay curve as you go to infinity? Isn't that going to be what? Doesn't this portion go to 0? So you say that, is that limit 6 times 0, which is 0? Absolutely, that limit is going to be a 0. So, ladies and gentlemen, this is having fun with L'Hopital's what? Rule. Should I dare do that? Oh, no. All right. Okay, let's go to let's try to do some indeterminate differences. So I'm going to give you guys something here. Let's recall from Calculus 1. Did you guys ever have an indeterminate difference? From Calculus 1, what's an indeterminate difference? So I'll give you a very simple indeterminate difference here. x cubed minus x as x gets big. That's a classic example. That's a calculus 1 kind of ish question. You say, well, what do you mean? Well, the difference of limits is the limit of a difference. So I got the limit of x cubed minus the limit of x. So this first limit's going to be what? Infinity. The second limit's infinity. This is your classic indeterminate difference. It's going to be that you have infinity minus infinity, or you have negative infinity plus infinity. Because we can rearrange the terms, so it's infinity minus infinity. You know, negative infinity plus infinity, and that's not 0, so don't say that's 0. Because remember, there's a rate of convergence. It could go to 0, or it could go to infinity, or it could go to minus infinity. Okay, so in a calculus 1 setting, what would you guys do in calculus 1? Anybody remember, what did you guys do here in calculus 1? What did you do? We said whenever you have an indeterminate difference, what do you guys use? Use what? Algebra. Is that true? So what was the algebra in calculus 1 that you used here? Anybody know? What was the algebra here? What's the only algebra you could use here? The only algebra you could use in that difference was to do what? Factor. Is that right? So what are you guys factoring out? You factor out the greatest common what? Factor. And then that, where did you learn how to factor the greatest common factor? A course called Beginning Algebra. Okay, so you say, what's the greatest common factor, the difference? X. So, okay, limit x goes to infinity. That's x times x squared minus 1. Is that true? Okay, do you guys remember factoring out an x term to the difference? And now this is a product, ladies and gentlemen. So I'm just reviving a calculus 1 question here. So what are the two limits now? Do you guys know? What are you going to get here for this first one? And then you get this for the second one. What do you guys get? That's going to be what? Infinity times what? What's the limit as x gets big for x squared minus 1? Could deduce it a couple of ways. Yeah, you can think of the parabola. That's what I do. Or how about thinking of it in terms of something big squared? Isn't that even bigger? And then subtracting 1, doesn't it not make a difference? So in other words, that's going to be what? Infinity, right? And then what's infinity times infinity? That's infinity. That is not an indeterminate product. Indeterminate products are 0 times infinity. This one's okay. And so, ladies and gentlemen, remember what that is. This is even thought of when I talk about this in calculus 1, end behavior. The end behavior for this function, x cubed minus x. So if I look at Desmos and say y will equal x cubed minus x, this is where you got that end behavior in your pre-calculus course and even calculus 1. What's the limit of that function as x gets big? Well, as you guys can see, as x gets big, what does the y value go to? Infinity, right? So, okay, you can even give people this question as x goes to minus infinity, and what do you think you're going to get? minus infinity. So you might even say, well, what do you want people to do? You want people to use the algebra to deduce the answer, not really look at the graph, although you can verify it with the graph. Because that's what it is. That's end behavior. Okay, you guys okay with that one? That's why you studied in pre-calculus some of those end behavior characteristics. This is really the math behind end behavior. Okay, well, that's a calculus 1-ish question. So you say, okay, what would be a calculus 2-ish question? So calculus 2 comes along, and you have something like this. E to the 2x minus 1 minus x over x squared. Okay, so you're kind of looking at a calculus 2 question. You might say, how do I know? Because you see e to the 2x. Okay, so what do you end up getting if you, as you apply x going to infinity? What does this become again? Infinity minus 1 minus infinity over infinity. Is that true? And then infinity minus 1 over here, you guys just got through seeing that made no difference, that's really still what? Infinity minus infinity over infinity. But I want to point this out to you. This here is a what here? Oops. What is this? Isn't that an indeterminate difference? What do you do when you have an indeterminate difference? What's that word? What's the dirty word in math these days? All right, let me take it back, not math. What's the dirty word in calculus these days? Algebra? Okay. It's a math dirty word. So they want us to use what? What was that rule? Use what? Algebra. So in calculus 1, the algebra changed depending on what you had. Is that true? So you might say, okay, I'm going to factor. And I'll say, how? Can't do that. Then what do you do? What's the only algebra that you guys can do here? What do you think? This is a problem-solving thing, you know. What's the only algebra you can do? I can only see one thing to do. See, that's kind of the thing about these questions. They're kind of all somewhat specially chosen. So what's the only thing you think you could do here? I see one thing. You know what you could do? Say e to the 2x over what? X squared? Minus 1 over x squared minus what? X over x squared? Is that right? And then so if I do that algebra, what did I do? Didn't I go through what? This is the algebra. All I did was divide every term by x squared, really. Because that's the only algebra I can do here. There's nothing else that I can look at here and say, well, what else can we do? Nothing else. Okay, I'm supposed to use algebra, I guess. So now, what's the limit as x goes to infinity of what you guys see here? This is the beauty of this question in a calculus 2 sense. What do you guys remember? What do properties of limits say? This is a limit of what? This limit of differences, is that right? So this now is going to be the limit here. X gets big of what? 1 over x. So back from calculus 1, I know this limit is 0. I know this limit is also what? 0. Is that right? Calculus 1 questions. The question's going to now be, what's that limit going to be? Anybody know what that is? I think that's infinity over what? Is that infinity over infinity? I guess so. Okay, now what do you think that means here? Right? What would that mean in this case? What do you think you have to use here? L'Hopital's rule. All right. So, all right. So the numerator is going to be what? E to the 2x times 2. What's the denominator? Is that 2x? So, this is the limit x goes to infinity. I think that's e to the 2x, right? Over x. What's that limit going to be? Is that infinity over infinity? I think so. So what do you use now again? L'Hopital's rule. So you're going to have e to the 2x again times 2 over 1. And so we get 2, pull out the constant. Limit as x goes to infinity, e to the 2x. And then this limit, since it's exponential growth, is that right? That's infinity. So what is the final answer going to be? Infinity. You might say, well, don't you have 2? Don't you have that constant 2 times infinity? Yeah, if you doubled Oprah money, that's still pretty big. Is that right? That's the whole idea, doubling. If you're doubling an infinity, that's, even though it's an idea, you can't really do finite math in that way, but it's the idea behind it. That's something that's doubly big. So it's big. We don't say, it's not algebra and finite. We don't say to infinity. It's just infinity. So that limit is actually infinity. And if you put this in the, you know, in the Desmos, you can say as x gets big, the answer is infinity. Okay, you guys okay with that? So this is kind of what's expected on the test. What's expected on the test is what? What is that dirty word? Algebra. Yeah, algebra. Anyway. All right. Should we see another calculus 2? That difference here? All right. Calculus 2. Limit as x goes to infinity. Ooh, this one. 1 square root of x minus 2 minus 4. X minus 4. All right. So, ladies and gentlemen, this is going to be an indeterminate difference. The first limit is infinity. The second is also what? Infinity. Is that true? And let me do something here, because I'm gonna just say from the right, because it's really a two-sided limit, and from both sides, it's gonna be the same answer: infinity minus infinity. So that's really what's hidden here. So let's try that from the right, and you get infinity minus infinity. So there's a way to deduce it again via calculus 1-ish. But what do you guys do if you have an indeterminate difference? What do you do here? What's that dreaded word? Let's get rid of that. The dreaded word is what? You use algebra. Yeah.
The limit is going to 4, or?
Yeah, x goes to 4. It's going to be a, which is 4. Yeah. So I just want to emphasize this. You can see going to infinity, you can see what? Minus infinity. You can see going to some finite value a. You can see a going to the right. All of these. So that's 4. Does anybody remember? Why do you guys know that this is what it is? Why is it infinity minus infinity from calculus 1? I mean, I don't want to go over calculus 1 really, because this is calculus 2. But you're looking at 4 from the right. Aren't those numbers bigger than 4? And as you get closer and closer to 4, you got a difference here that's small. So 1 over something very small is very what? Big. Is that true? And then over here, that difference is also what? Small. 1 over small is very big. And there was already the difference here. So I just want you guys, if you go back to those kind of things, calculus 1, that's how you kind of deduce the infinity minus infinity. We did look at numerical methods in calculus 1 as well. I thoroughly did that for calculus students, you know. But anyway. And yeah, 1 over something very small is very big. Okay, what about the algebra, though? You go, oh, Mr. Judge, what do you mean algebra? I got to use what again? Algebra. Can I do the algebra that I did in the last question? What do you think? Can I do that algebra? No. I can't divide, right? I can't divide every term like I did here by x squared, the only algebra. Okay. Can I factor here? No. So what's the only algebra you can do? The only algebra. Let's scout out another algorithm for algebra. What do you guys think? A over B minus C over what? What is that? Do you guys remember? That's a difference of fractions. Is that true? How do you guys subtract fractions that have different denominators? Do you guys remember this algorithm? Let me show you an algorithm. Okay, so what do you guys have here? What's this going to be? AD minus BC over B what? D. Okay, is that right? You guys okay with that? Do you guys remember that algorithm? Where this is the cross product for the numerator, and then you do this horizontal product for the denominator. So that's what you guys want to do here. So now, that's the limit as x goes to 4. We can say from the right again. X minus 4 times 1 is x minus 4. And then this is minus 4 times the square root of x minus 2. And in the denominator, we have the square root of x minus 2 times x minus 4. Okay. So I think what you want to do is distribute here and simplify to get the limit x goes to 4 from the right, x minus 4 minus 4 square root of x plus 8. Square root of x minus 2 over x minus 4 now. And then, what's this portion here going to give you? I know I can do that. I know it's hard for you guys. What's negative 4 plus 8? Isn't that going to be plus 4? Is that right? Okay. So I apologize for doing that to you,
because I know that means you have to write it all down, but okay. All right. So what's this limit going to be? Do you guys know what this limit's going to be? If you apply that limit as x goes to 4 now, what's that going to be? Replace this x with a nice what? 4. What do you get? You get 4 minus 4 square root of 4 plus 4 in the numerator position. You get the square root of 4 minus 2 over 4 minus 4 in the denominator. Square root of 4 is really going to be 2. 4 times 2 is 8. You get 0 over, this is going to be 2. 0 times 0 is 0. Oh my. My. This is an indeterminate what? Quotient. Okay, you guys okay with that? So because you have an indeterminate quotient, what do? L'Hopital's rule. So just to kind of go with the details here, what do you think you're going to have to do, ladies and gentlemen? You're going to have to do a derivative. Is that right? Okay, here's what I want to remark here. You might want to simplify this here before you take a derivative. You're going to have to use power rules up here, down here. Is that right? Sorry, not power rule. I take it back. Product rule. But if you did FOIL here, first, what do you guys get? Isn't this x, square root of x, the first term? The outer term is minus 4 square root of x. Your inner term is minus 2x. Your last term is plus what? 8. Is that true? So what I'm going to say, what I've done for these questions personally is done the algebra. And then over here, x times x to the square root of x, isn't that x to the 3/2? All right. Now apply your L'Hopital's rule. One minus 4 over 2 square root of x over 3/2 x. 3/2 minus 2/2. 3/2 minus 1. X to the 1/2 minus 4 over 2 square root of x minus 2. So I'm doing those derivatives here. So if I kind of write it a little bit neater and I simplify, I get 3 square root of x over 2 minus, again, 2 over square root of x minus that 2. All right, so what I'm going to do now is I'm going to simplify here. Well, I shouldn't say simplify. I'm going to subtract here. Because I am going to simplify, but I'm going to subtract everything here. What I'm going to try to do is add my numerators. So I'm going to replace that with square root of x over the square root of x, because that's 1. here. Okay, so down here, square root of x times 2 times 2. And then here you're going to have what? 2 square root of x over 2 square root of x. Because we're going to do our arithmetic here. We're going to subtract our rationals. You got to have the same denominator. So to get the same denominator, you'll have the square root of x minus 2 over that square root of x over 3x minus 4 minus 4 square root of x, everything over 2 square root of x. Now you might say, why do you want to even do that? Well, isn't this a complex fraction where your radical goes away? And so you're going to end up with just doing some of that algebra again. X goes to 4 from the right. You get the square root of x minus 2 over, I'll put it this way here. 3/2 x minus 2 minus 2 square root of x. Ladies and gentlemen, double check to see if my arithmetic is okay. I believe it is. All right, you guys ready for this now? I think our arithmetic is okay. What do we do with this limit then? You apply what? 4, is that right? So the square root of 4 minus 2, 2 minus 2, isn't this going to be 0? And if I plug in a 4 here, right, don't I get 6 minus 2 minus, square root of 4 is 2. 6 minus 2 minus 4, oh, I get what? 0 over 0. So if I plug in the 4 everywhere. All right, so what do you think that means? I got to use what again? L'Hopital's rule again. So we use L'Hopital's rule. Okay. Limit x goes to 4. Take the derivative of the square root of x minus 2. It's 1 over 2 square root of x. Remember I said memorize that derivative? Shows up a lot, right? Memorize that derivative. That shows up all throughout the course. So if you already know it, oh my God, you could use it. So that's 3/2 minus 2 over 2 square root of x. I did it again. So if I can simplify again, 1 over 2 square root of x over 3/2 minus 1 square root of x. All right. Hopefully I don't get an indeterminate form when I do what? Plug in 4. Okay, so this is 1 over 2 square root of 4, 3/2 minus 1 square root of 4. Square root of 4 we know is what? 2. So we have 1/4 over 3/2 minus 1/2. And I think that's going to be 2/2, which is 1. So 1/4 divided by 1. Ladies and gentlemen, the limit is going to be what? 1/4. Anyway. Okay. So we're going to stop right there so you can pass back your exams. And, you know, those 8 of you guys at home, I just want to share with you guys, come to class to pick up your what? Your exams. Okay, let me explain a few things for you guys. Now,
Well, first of all, did I put your homework in Canvas yesterday? Okay. Assignment section. It's in the book. 7.7. If you need to take a photocopy of the questions and answers, please do. It's already there. Okay. We're not done with the section. We got to do indeterminate powers tomorrow. We're going to try that out too. But back to the test information. Believe it or not, there were 56 check mark opportunities. You might say 56 checks is 56 things I look for every test. You're like, whoa. If it's there, you get a check. If it's not there, you don't get a check, right? So how you get your score, by the way, is the number of checks divided by 56 times what? 150. And then you say, well, how do you get your grade? Well, 152, 135 is an A, 134 to 120 is a B, 119 to 105 is a C, 104 to 90 is a D. 89 to 0 is a fantastic. Now, do I drop your lowest test score and I replace it with your final exam grade, the prorated points? Anybody remember the syllabus in the first day? Did I talk about that? Yeah. So anyway, and then this is a true story. I did have a calculus student. Unfortunately, the whole course, he didn't know he was failing. He said he just didn't know. Somebody lost their ID. Christopher Baker here? No? Anyway, you know why he didn't know he was failing? I wish I knew. I didn't believe him. Trust me, there are people that say things all the time that are not true. Anyway, so I want to talk a little bit about it because at this point, your point-wise, if you look in Canvas, 100% to what? 90% is an A, right? 89% to 80% will be a what? A B, because Canvas has your grades, overall grades in terms of a percentage. So you can understand where you're at. And then 79% to 70% is a C. 69% to 60% is a D. 59% to 0 is a fantastic. So, so you should know these kind of things. But okay, if you don't, well then now you know. But it doesn't change your reality if you don't know, but okay. So in that case with that student, it's like, sorry, you're failing. If you don't understand the percentage of points, then okay. People always look for somebody to blame. It's never their fault. So there you go. This is the points, so this is where you're at. Now, could I predict how you're going to end? No, why not? Because you haven't done test 2, 3, 4, final. We haven't dropped your final, replace it with your lowest test score. So there's a lot to be determined. So even if you fail this first test, you can still get an A. You go, really? How's that possible? I've had that happen. I don't think I've had it in a calculus class, but I've had it in other classes. Because you drop your lowest test score, replace it with your final exam grade. What if you get an A in the final? Then, you get an A on that lowest test score. So easy. So we got to give people all these little details. It's kind of like a drag because sometimes it's like most people are fine. They understand. Everybody gets it. Bless you. But, sometimes you do have to go through this with all your classes. You got to remind them. So all my classes giving back the test, you got to let them know all these little details. So what I'll do again tomorrow, we'll continue with L'Hopital's rule. You have your homework, and I'll pass back your test. But I have to say, your solutions are ready. They're even in Canvas, but they're not public. I have to hold on to them for a little bit. And then when I can let them go to you, I will let them go to you. And I'll even contact you in Canvas. So anyway, ladies and gentlemen, okay, so we'll pass back your tests, and you get to leave once you get it. All right? So you remember, you guys did fantastic. So all the stuff I'm talking about isn't about you because you did what? You did fantastic. Should we name the people that got 100% on the test? No? Good. You know why? You don't want anybody to know. Why not? Do you guys know what kind of scores I used to get on my math test? Just don't tell anybody. And my physics exams? 100%. Used to get 100%. Just don't tell everybody. There's a secret. I'll tell you the secret next time. But the reason I say don't tell anybody, what happens when people find out you get 100%? What do you think happens? Nobody knows what happens? Then all of a sudden people want to study with you. And they say, hey, can we study together? Wink, wink. And you're like, okay. But what are they really saying? Tutor me. No, maybe times have changed. Maybe it's different now because we have tutoring centers. But back in the day, we didn't have tutoring centers. So if you got 100%, that was always code for somebody if they knew. They always wanted to study with you, and then they were busy having you tutor them. Then you couldn't study for yourself. So used to have to hide. When people found out 100%, I hid in the library, the bottom floor. And people would come looking for you. And I'd always hide in the back, in the corner. Because people wanted you to tutor them. We didn't have tutoring labs back then. So now you guys have tutoring labs. Anyway, times have changed. Maybe that doesn't happen to you guys. All right, we'll see you guys tomorrow, and let's pass back your test.